Our next unit is solving proportions. So first of all, we need to understand what a proportion is. And in order to understand a proportion, we have to know what a ratio is. A ratio is simply a comparison of two numbers. Typically, we'll see it represented as a fraction, but it doesn't always have to be. A proportion is when two ratios are equal to each other. An example of a proportion you might recognize would be that 2/3 equals 6/9. It's the simplified version of 6/9. Our essential question, we're still applying that golden rule of algebra, this time to solving proportions. So we're starting off with a simple proportion, and the golden rule is whatever we do to one side, we do to the other. So our first proportion, we have our variable divided by 12. So in order to cancel that division, we're going to multiply both sides by 12. So of course, on the right-hand side, our 12s cancel, leaving us with m, which is what we want to solve for. And on the left-hand side, 12 and 8 both have a common factor, so I can divide them both by 4. 8 divided by 4 gives me 2. 12 divided by 4 gives me 3. So I'll take my 3 times 7, which gives me 21, over 2. This way I get my fraction in simplest form right away, instead of having to multiply 12 by 7 and then simplify that by 8. It's a little bit easier to cancel before you multiply. Next, we're going to take a look at a proportion that has a binomial. A binomial is when you have addition or subtraction of two terms. So we've got that in the numerator on the right-hand side. We're still going to be using our golden rule to solve. So the first thing I'm going to do is multiply both sides by 6 to isolate the binomial. So on the right-hand side, we simply have our 2n plus 4. It's really tempting for students to want to distribute that 6 into the binomial, but resist that temptation. We're trying to solve for the variable, so you should be canceling. On the left-hand side, we can't simplify our 6 over 5, so we have 6n over 5. Now we want to cancel that denominator as well, so now I'm going to multiply both sides by 5. Remember, I'm going to multiply the entire side by 5, so now I will have to distribute on the right. On the left, my 5's cancel, leaving me with 6n. On the right-hand side, distributing that 5 in, I have 10n plus 20. And then I can get my variables together. I want to move the 10n over. This time I'm moving the term with the larger coefficient because if I moved that 6n, there would be nothing left on the left-hand side. So we've got negative 4, n equals 2. To solve for n, I'm dividing both sides by negative 4. On the left-hand side, my negatives 4 cancel, leaving me with n. On the right-hand side, I get a fraction. I'm going to put it in simplest terms, and I'm going to move the negative to the numerator because when we simplify fractions, we put the negative either in the numerator or out front, but never leaving it in the denominator. And of course, 2/4, dividing each of those by 2, we get negative 1/2. Next, we're going to take a look at how to solve a proportion with a variable in the denominator. What we want is to get the variable out of the denominator. So we're going to apply the golden rule, but it's going to be a little bit different than we've seen it so far. What I'm going to do is flip both sides of the proportion. What I'm doing to one side, I'm doing to the other, so this is legal, and it gets my variable in the numerator where I want it. Now I can multiply both sides by 3 to cancel that division by 3, leaving me with g on the left-hand side. And on the right-hand side, 3 goes into 9 3 times, so I get 10/3 for my answer. All right, last example. This time we have binomials both in the denominator. I'm going to apply the golden rule and flip both of my proportions. So I get d plus 9 over negative 2 equals 4d plus 1 all over negative 3. It does not matter which denominator you cancel first. You can also cancel them at the same time. So I can show you how that works if you can follow this example. Otherwise, just think back to the one where we canceled it one at a time. So I'm going to multiply both sides by -2 to cancel the -2 on the left-hand side. And I'm going to multiply both sides by -3 to cancel the division by -3 on the right-hand side. So what happens is I'm distributing the -3 on the left-hand side, giving me -3d minus 27. On the right-hand side, I'm going to distribute the -2, and I get -8d minus 2. Now I want to get my variables together. -8 is less than -3, so I'm going to add 8d to both sides. On the left-hand side, I get 5d minus 27. On the right-hand side, after my 8d's cancel, I'm left with -2. Adding 27 to cancel my -27. Golden rule, adding the 27 to both sides. I get 5d equals 25. And finally, dividing both sides by 5, I get d equals 5. And here are 2 you try problems. Come to class with these attempted so we can start off with our warm-up.